Good afternoon, class. We are looking at exam 2 covering chapters 3 and 4. Chapter 3 is about functions, and chapter 4 about linear functions. So the very first thing, we are given a bunch of graphs. We should be able to recognize all of them. We want it in that order. You don't have to even look at that to figure things out. Okay. Just for the sake of argument, you should recognize this is y equals x cubed. This is the absolute value function. This is y equals x squared. This is y equals square root of x, so on and so forth. You should recognize it. And so we're going to put in that order. This is cube root of x. Absolute value of x looks like a V shape. 1 over x squared. 1 over x. In essence, this part flips over and gets larger when we go to 1 over x squared. The negative portion flips over, the positive portion remains. This is y, or f of x equals x. This is y, or f of x equals x cubed. This is the quadratic function, y equals x squared. This is a square root function, y equals square root of x. And there you have it. So just in case, I don't think anybody has any problem with that, but just wanted to make sure that you recognize it is important to know elementary functions. The next question is, given f of x, we want to evaluate this, which means replace the x with x plus h. Now x plus h squared is x squared plus 2xh plus h squared. And this one is 4x plus 4h. When you distribute, you get minus 5x squared, minus 10xh, minus 5h squared. The rest of them repeat. Nothing simplifies. To calculate this, basically you have a fraction bar. The denominator is h. This one has been calculated minus f of x. So this is right here, and this, and h is right there, and f of x is this one. So all you have to do, simplify the numerator. I'm going to distribute the negative sign. So I get plus 5x squared minus 4x minus 7 minus 5x squared, positive 5x squared cancel each other. Positive 4x minus 4x cancel each other. Positive 7 minus 7 cancel each other. So we are left with this one, and this one, which means we can factor the h out from the numerator. We get minus 10x minus 5h plus 4. So that's the numerator. I drop the h with h. This is the final answer. So select all that represent a function. Remember, in short, the x coordinates cannot repeat. So for example, this one, we have x that repeats, so this is out. This one, the x coordinates do not repeat. This one, the y coordinates repeat. It's okay. So this one and this one is fine. This one is also fine, but this is not. Now, for the, so these two, doesn't matter the y, because the y repeats, it's not a one-to-one function, but it is still a function. So we are interested in a function. And this works too. Why is that? Because it passes the VLT, vertical line test. Okay. Whereas this one fails. Look at them. For example, those pairs have the same x coordinates. We want to find the domain. We don't even have to look at the possible solution. We go through the process. In order to find the domain, we set the denominator equal to 0 and exclude that. So factoring this, I'm assuming everybody's okay with that. When two numbers, the product is negative 60, the sum is 7. We get plus 12 and minus 5. So x is either negative 12 or 5. These are the numbers that make the denominator 0. We must exclude those. To exclude those, the way they are given, we can write them in this format. However, if they said put it in interval notation, then you would put minus infinity, minus 12, union minus 12, comma 5, union 5 infinity. In case if they ask you to put it in this format, you should be able to handle it. We want the domain and range. So as you can see, it starts from here, covers everything on the x-axis from negative 1 to 2, except 2, and that's why we have the parentheses, everybody. Except 2. For the range along the y-axis, doesn't cover this one because there is a hole, but it covers everything here all the way to here. So the range is from 0 to 4 except 0. And that's why we have a parentheses on the left side. Given the function, we want to calculate the following. So it's important to know which one we use. F of minus 1. When x is less than 0, we are here. So less than 0. So plug in negative 1. 2 times negative 1. So let's just. So we are going to use 2x plus 2. And here's another notation, which I'm telling the reader which part. Whenever it's piecewise defined function, we can tell the reader which portion we are using. That becomes 0. For 0, because of the equality, we are going to use this one. That means we are going to use 2x plus 4 when x is 0, which makes it 2 times 0 plus 4 equals 4. And for 2 also, we're going to use the same thing, 2x plus 4 at x equals 2, which makes it 2 times 2, 4 plus 4 equals 8. All right. We want to graph a piecewise defined function. Now, what my suggestion is that first you can graph each piece individually and then figure out where you should stop. For example, for this one, I can graph y equals negative 3, which is a horizontal line in general, okay? So I'm going to call it y sub 1. The second one, y sub 2, I'm going to graph x minus 1, which is a line. And if I were to use intercepts, then x is 0, y is negative 1, and y0, x is 1. So it's this line. Again, we are not paying any attention to the restriction yet. And for this one, just graph y sub t3 equals -2, which is also a horizontal. Now we want to put this together by paying attention to the restriction. So when we go back to the restriction, it says this works when x is less than or equal to -2. So here's -2. Okay. They happen to come together, by the way, here. So you have a point here, and for y equals -3, this portion is out. I cross it out. This is no good. Only the left side of it is good. Then it's x minus 1 from -2 to 2. So this portion is not good. Okay. And this is a hole for the green line. However, the hole and the solid point, they come together and it makes it a solid point. So all the way to x equals 2, when x equals 2, in this case, when x equals 2, y equals 1. So this, to this point is fine, solid. You drop this portion. I hope everybody can see what I'm doing here. And finally, we have y sub 3 equals -2, which starts from 2, and that means from here is good to the right of it, and this portion is not good. So what you're looking at, let me use a different color. Let's see what color would be good. Maybe this one. This is good. This is good. This is good, which looks like this one. So this is a piecewise defined function. So again, one easy way, graph each piece and then keep the portion that you need. All right, I'm going to find the average rate of change of g of x from -1 to 2. And remember, average rate of change, that's really the definition of a slope. And these are different ways of writing this slope. Rise over run. In this case, and according to this definition, we want g of 2 minus, in this case, it's g. So we want g of 2 minus g of -1 over 2 minus -1. This is g. So plug in 2 minus plug in -1. The bottom is 2 plus 1 is 3. So the bottom is 3. This is 8 times -5 minus 40, and 5 is -35. This is -1 times -5 is 5, and 5 is 10. So what you have, -35 minus 10 or -45 is your numerator. Divide by 3, you get -15 as the final answer. Let me fix this. And remember again, there's a negative sign in between, which makes it -45. Divided by 3 is -50. Estimate the intervals where the function is increasing or decreasing. So it's increasing here. So along the x-axis means from here, this way. So from -1 to infinity is increasing. It's decreasing here. So this way is decreasing. So negative infinity to -1. Or you might say x is less than -1. In this, if you go that route, you can say x is larger than negative. Determine the local extrema, local max or mean. Determine the absolute or global. This is also called relative. Let me just write it. This is also called global. And minimum or maximum together, we call them extrema. All right. So in this case, this point is a local mean, also an absolute mean. So local mean, the same as absolute mean, equals to the y coordinate of this point, which is -2 at x equals -1, or this pair. Now, the way they ask you a question, you want to answer them accordingly. They may ask you to answer them as a pair. They may ask you what is the local mean or absolute mean. It's -2. It's the y coordinate. And what about the maximum? It doesn't exist. We don't have a local max. We don't have a local, we don't have an absolute max, none of the above. And this question says, find the same thing, absolute max or mean, but they want it in ordered pairs. Normally, they should really ask you what is the absolute max and where is it located. But anyways, so absolute max is right here. And the pair, the way they want it is in a pair, so 0, 4. Absolute mean is here. They want it in a pair format, 3, -5. But the proper writing, and I want to write it here because you really want to pay attention to the way they ask you to receive full credit. So absolute max equals 4 at the pair 0, 4. Absolute mean equals -5 at this pair. So that's really the more proper way of doing it. Consider the function in the graph to the right. The function has a maximum of. So it's important to know that there is no absolute max, there is no absolute mean, but this is a local max, this is a local mean, and that's what they are referring to. So we are looking at this point, and this point has coordinates -3 and 5. So what is the maximum? The maximum is 5 at x equals -3. And again, you may write it as maximum equals 5 at -3, 5. So however they want it. The minimum is here, having coordinates -1 and 3. So the minimum is equal to 3 at x equals -1. The function is increasing here, which means to the left of this point. And here, which means to the right of this point. We have -infinity, -3, union -1 to infinity. The function is decreasing here, which means in between here, from -3 to -1. The domain and range are both sky's the limit, all real numbers. You can write it in this format or in this format, however they ask you. So it's all real numbers. Here's the function 3x plus 3 and g of x equals 5x squared plus 3x. We are going to simplify and find f of g of x. Well, it's a composite function of f of g, which is f of g of x. And that means put the g in here. 3 times 5x squared plus 3x. So replacing the x with the g. Now distributing gives us 15x squared here, 9x here, and then plus 3 remains. Now f of x is x plus 4, g of x is x minus 3, and h of x is square root of x. So we have 3 different functions. We want f of g of h of x. So to find that, first let's find g of h of x. So g of h of x, here's the g function, and you replace the x with square root of x. And now this goes in here. So replace this x, that means now square root of x minus 3 to the power of 4 cubed. Now, I hope everybody knows that if you, and you don't have to, raise this to the power of 4, but if you want, you have to use what's called binomial theorem. So it's not just that you raise to this to the power of 4 and the same thing to the power of 4. That's not what happens. Okay, so this is the answer as far as you're concerned. H of x is given as x plus 1 to the power of 5. It can be expressed in the form of f of g. So this is f of g of x, where f of x is x to the power of 5. And g of x, it's a matter of inspection. So how do you change this to this if you change the x to x plus 1? Do you see that? Therefore, g must be x plus 1. It's just by inspection. So answer by inspection. There's no way around. Just check it out. And note that f of g is f of g of x is x plus 1 to the power of 5. After you come up with the answer, you want to check it always. The next one is asking f of x is 2 square root of x. If g of x is the graph of f of x, shifted down 4 units. I want you to ignore that. Let's write this. If you want to shift it down 4 units, so minus 4. And now you want to take it to the right by 2 units. So x changes to x minus 2. So 1 step, 2 steps, and we are done. We want to come up with the functions. First and foremost, this one is the basic f of x equals 2 to the power of x. They called it k, it doesn't matter. So 2 to the power of any exponential function of the form a to the power of x, where a is not 1 and a is larger than 1, looks like that almost, meaning if this is 3 to the power of x, 5 to the power of 10 to the power of x, looks almost like this. Okay, exponential growth, if you will. Okay. Now we want to figure out which one is which. Well, if you flip this over with respect to the y-axis, just change it to the red one. So flip this over with respect to the y-axis. That means you're going to change the x to minus x. I'll go back to the original one. Back to the original one. If I flip this with respect to the x-axis, flip it this way, it gives me the blue one. And so basically, you're negating your y coordinate. So you put a negative in front of that. So the blue one is negative 2 to the power of x. Now, if you now reflected with respect to the y-axis, it gives you the green one. So this remains and x changes to minus x. Okay, so I hope everybody can see what we did here. Here's f of x, 8 to the power of x. We're going to move it 2 units up, so plus 2. Same function, 4 units to the right. So we change the x to x minus 4. Same function, this time we're going to reflect it about the x-axis. That means the y becomes negative. That means you put a negative in front of the whole thing. This is the y function, right? And then the y-axis. Okay, now you're going to change the x also. If you stop at this point, you put a negative sign here. And the y-axis, you put a negative sign in front of x. So you have both of them. Describe a function g of x in terms of f of x. If the graph of g is obtained by vertical stretching of f by a factor of 8, then shifting the graph of f to the right 2 units and upward 3 units. So here's g, and we have f of x. So inside the parentheses, we put plus b, and then outside we multiplied by a, and we add a constant. We want to see what happens. So basically, what we are saying, this is a vertical stretch. So a is replaced with 8. This one, if we move to the right, we get minus 2. If we move to the left, we get plus 2. So in this case, move to the right, minus whatever this number is, minus 2. We're going to go up by 3. So this is up and down. If it was down, minus 3, since it's up, plus 3. So those are the transformations. We want to match the functions. We notice all of them are quadratic functions. So we write the quadratic function in its vertex format of a times x minus h quantity squared plus k. And we look for the vertex. We notice the vertex is located at -1, -5. So, I mean, since it's a multiple choice, just look for the vertex of -1, -5. So, for example, this one is located at +1, 5. This one has -1, +5. These two are out. This one is located at 1, 5, but we want -1. This one seems to be located in the right place, so that's the answer. And of course, if you find an easy point, you can always check it. Something that is very clear. Okay. All right. Let's move on. When I say a point that you can definitely have the pairs, you put it into this, making sure it works. And it's sometimes hard to see because it may not be to scale. All right, we want to sketch this graph, and we notice an absolute value. So we start with the V shape. Remember the very first question. That is the absolute value function. I'm going to go with the order of operations. I notice there's a +3 here. That means I'm going to move to the left by 3. So the vertex is at 0, 0 for this guy. Now x +3, I'm going to move it to the left. It looks like that. So here's the vertex, and here's the new vertex. The vertex is here 0, 0, and over here is located at -3, 0. Again, I'm following the order of operations. So first I'm going to stretch it by +2. I'm going to look at +2, not negative yet. So +2, when I stretch this, basically this gets closer and closer to up here along the y-axis. Okay, so I multiplied by 2, looking like that. Now I'm going to put the negative sign. If I put a negative sign, this will flip over. Okay, it flip over. So the blue one, now it's the green one. It flipped over with respect to the x-axis. So I'm here. I need to add 2. So I'm going to take the green one up just the way it is. So this one goes up such that the new vertex is here, and it looks like that. So the new vertex is here. Located at the same x-coordinate of -3, shifted up 2 units. It's pretty straightforward. All right, we want to find the x-intercepts, and I hope you remember from module 1 how we solve absolute value equalities. So in order to find x-intercepts, y or f of x is 0. And so we're going to isolate this, meaning I'm going to move the 6 and I'm going to divide by 5. And now I make up 2 equations. I drop the absolute value and I say plus minus. I'm going to move the 1 to the right. And now I have 1 minus 6/5, which is -1/5, and 1 plus 6/5, which is 11/5. And what this really means is the following pair: -1/5, 0, 11/5, 0. And the reason I like to use a pair because it's asking for the x-intercepts. If they didn't ask you for a pair, you can leave it like that, but I want to make sure everybody knows what's going on. So given the graph, we want to find f of 0. That means when x is 0, what is y? That's the meaning of it. So this location has the pair 0, 4. Therefore, the answer is 4. Now, f of x equals 0. That means where is the y 0? That means this pair having coordinates 2, 0, x becomes 2. So that's pretty straightforward. When I look at part C and I go with the inverse, I want to understand the concept of an inverse. So I'm going to remind you that if A and B, and here's the notation, an element of, I've discussed that before, is an element of f of x, that means it belongs, so this pair belongs to the function f of x, then B comma A belongs to, it's an element of its inverse. So for example, right now, we can see that 0, 4 right from here belongs to the function f of x. So what does that mean? Or 0 belongs to its inverse. So we want f inverse of 0. Let's also write this one. This means 2, 0 belongs to f of x. And let me use a different color. And therefore, 0, 2 is an element of its inverse. So that's the meaning we should know. So this means that, this means that. We want f inverse of 0, we want this pair. The answer must be 2. F inverse of x equals 0, that means the y is 0. The y is 0. What is x? 4. Okay. Given a table, we want to come up with its inverse. Instead of choosing, I just didn't pick up the tables, we're going to make it up. All you have to do, interchange x and y. So all the y's become x, all the x's become y. That's all. So we are changing it. X was 2, y was 3. It's the other way around. So interchange x and y, and that's a new table that you're looking for. We want to find the inverse. First, we change f of x to y because it makes it easier. Then we change y to x and x to y, and this is the inverse. However, we always solve for y, which means I'm going to move the 7. And now I'm going to raise both sides to 3. And the right side basically becomes 1, becomes y. And so y is x minus 7 cubed. And I call it f inverse. Now, to prove that, I'm going to look at one of them. I'm going to look at f of f inverse, f inverse, and that must be equal to x. Let's see if that's the case. I'm checking that. So f of f inverse equals 7 plus cube root of x minus 7 quantity cubed. This becomes 7. This becomes plus x minus 7. And as you can see, it is equal to x, and it does check. F of x is given, g of x is given, and we want to find f of g of x. So basically, replace the x with the g, which is x minus 9. And negative 9 cancels out the 9, we get x. Gf of x, replace the x with f, which is x plus 9. They cancel each other, 9 and negative 9, we get x. So what does it mean? Because f of g equals g of f equals x, the two functions must be inverse of each other. We proved the two functions are inverse functions. We want to find the inverse. First, we change the f of x to y. Then we interchange x and y. To solve for y, I'm going to move the negative 2 to the left side, becomes positive 2. Then I'm going to divide by 5. So this becomes y, and I call it f inverse. And to prove, I'm going to look at f of f inverse, which is 5 times x minus 2. And instead of x, I'm going to put x plus 2 over 5. So I want to prove that I haven't made a mistake. So this is x plus 2 minus 2. Since their composite function f of f inverse is x, they are inverse of each other. And as you know, two functions that are inverse functions, they are symmetric with respect to the line y equals x. Y equals x. So basically you have to put x here. Y equals x. A city's population in the year 1998 was 3,231,800. In 63, it was 3,216,050, and we want to calculate the slope. Well, if they said calculate the slope or the average rate of change, it means the same. So time and population, time is the independent variable, and the population y depends on that. So we have the pair x comma y, and for this one, we're going to write this 2, and for this one, we're going to write this 2. And now we use m equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1, rise over run. We just plug in. So replace them accordingly. Simplify into 450, and that means the population is increasing at a rate of 450 people per year. As far as the units are concerned, the units of the numerator over the units of the denominator. That's how you come up with that. The numerator is the difference in population, so number of people, and the denominator is the time in years. So therefore, units of the top over the units of the bottom gives us people per year. People per year. On a bicycle, Janet rides for 3 hours and is 8 miles from her house. After riding for 12 hours, she is 26 miles away. What is Janet's rate? And rise over run, y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So the difference in mileage, 26, so we can write the pairs if you will. We can write this as 3, 8, this as 1226. And by the way, this is hours, this is miles. So right away, when you're done, the units would be miles or hours. So 26 minus 8, 12 minus 3, which makes it 18 over 9 equals 2 miles per hour. A phone company charges for service according to formula C of n is 23 plus 0.03 n, where n is the number of minutes talked, and C of n is the monthly charge. The rate of change in this equation. The rate of change is always the slope, everybody, which happened to be 0.03. So rate of change, the slope represents the change in cost per minute of call for the amount of $0.03 per minute. What is the initial value? Initial value refers to what happens if n is 0, which is 23. If you replace n with 0, it becomes 23, which is, in the case of y equals mx plus b, is the y-intercept. In this case, we call it the c-intercept. So let me just rewrite this, and I want to show you what happens. This if I were to rewrite it again, would be c equals 0.03 n plus 23 would be m. If we go with y, mx plus b. In this case, of course, x is replaced with n, b is replaced with 23, and y is replaced with c. So what you're looking at, the value of b is the initial value or the y-intercept. Over here, we call it the c-intercept. That's the initial value. So the c-intercept represents the fixed monthly cost or flat fee charged by company, which is $23, and it's the initial value. The phone company has a monthly cellular plan where a customer pays a flat monthly fee and then a certain amount of money per minute used on the phone. If the customer uses 380 minutes, the monthly cost will be $187. The customer uses 760 minutes, it will be $339. So first and foremost, when you find an equation of the form y equals mx plus b, where x is the number of monthly minutes and y is the total monthly of the plan. So minutes and cost would be x and y. So minutes is the independent variable. So we have 380, 187, 760, 339. So we have two pairs. We're going to calculate the slope, which is rise over run. Y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So 339 minus 187 over 760 minus 380. That's 152 over 380, and it's 0.4. And everybody remembers the point slope y minus y1 equals m times x minus x sub 1. So we're going to write c minus c sub 1. C minus c sub 1. And you use one of those pairs. For example, minus 187 equals m 0.4, x minus x sub 1, x minus 3. Bear in mind, if you use this point, it looks like this, and I'm going to repeat something we have talked about before. C minus 339 or 0.4, x minus 760, and if you work it out, ends up being the same. So you distribute the 0.4, and you move the negative 187, and that's your final answer. COC of x. Use the equation to find the total monthly cost if 940 minutes are used. So simply put, replace the x with 940. 0.4 times 940 is 376. With 35 is $411.